Hey there, y'all. Today we're going to look at 2.2 on solving multi-step equations. And so in this section, we're going to look at how to solve multi-step equations, including those involving fractions. And then we're going to look at the standards like we looked at yesterday with AREI1 and AREI3, dealing with the solving and writing of equations in one variable. And so got a couple examples we're going to look at here today. This is a shorter lesson. So let's look at this first example here. So we've got 3 parentheses 4x minus 5 is equal to 21. And so in this example, we see that it is 3 parentheses 4x minus 5 equals 21. And so we could do this in one of two ways. And we talked about this in the video for 2.1, that we can either distribute this 3 in or we can divide by it, remember? And so it depends on what's on the other side. Now, I've got 21 over here, right? So I could divide this both by 3, get it to cancel, and it comes out nicely, right? Because 21 divided by 3 is 7. Or I could distribute this in and then deal with dividing later on in the problem. And if it comes out to a fraction, it comes out at the very end instead of at the start of the problem. So in this case, I will divide both sides by 3. And when we do that, we get 4x minus 5 is equal to 7. Now at this point, I don't need the parentheses. I can actually drop those away because there's nothing outside to affect it. And then from here, we're, again, still using our PEMDAS, right? Working our way up the list. And so now I've got this minus 5, so it means we're going to add 5 using the inverse operation. And so 4x is equal to 12. And then my final step here is to divide both sides by the 4. Then I get that x is equal to 3. And like we talked about in the 2.1 video, check your work. Remember, if you'll check your work, you'll know you have it right or wrong before you even ask me a question, right? Check your work. And so when we substitute this back in, we're going to get the 3, 4, and then we've got the parentheses of our substitution, the 3, minus the 5, is equal to 21. Is that equal to 21, right? And so remember, we're working inside. 4 times the 3 is 12, minus 5. 12 minus 5 is 7. And then 3 times 7 is 21. And so that checks out. So my answer is that x is equal to 3. So again, make sure you follow your steps and then check your work. So let's go ahead and look at example B. So as we look at example B here, we see that we've got a fraction. 2x minus 9 all over 5 is equal to negative 7. And so like in the problems we looked at in lesson 1, we need to get rid of that denominator first. And so remember that a fraction is division. And so to undo division, we're going to do multiplication. And so we're going to multiply both sides by the 5. And so the 5s here will cancel. And so I get 2x minus the 9 is equal to negative 35. Remember that on the left side, that 5 is not going to multiply to anything in the numerator. The whole point is that it cancels that denominator. From here, it looks like the problems that we looked at in section 1. And so we can add 9 to both sides. And we get that 2x is equal to negative 26. And then our final step, let's divide both sides by the 2. And we get that x is equal to negative 13. And again, once you get your answer, you need to do what? Check your work. And so we're going to plug this back in. 2 times the negative 13 minus 9 over 5. Is that equal to negative 7? And so remember, we treat the numerator of this fraction like it is a parentheses. And so we'll do everything in the numerator first. And so 2 times the negative 13 is negative 26. Minus 9 over 5 equals negative 7. Negative 26 minus 9 is negative 35. And negative 35 divided by 5 is negative 7. So this answer does check out. So that's where we're at there. Again, follow the steps. Make sure that you are working through PEMDAS. Now, I could show you 20 more examples of these, but the steps are all going to be the same. We've got to just keep unpeeling that onion every step that we take. We've got to get there. We've just got to work through addition, subtraction, multiplication, division, exponents, which we won't have many of in these problems, and then parentheses. So that's where we're at there. So as we look at example 2 on how to write these word problems out, again, we're going to be dealing with problems that have multiple steps and multiple things to include in the problem. And so let's read through this one and see the information that we have. A ticket agency sells tickets to a football game. The agency charges $28 per ticket, a convenience fee of $2.75, and a shipping fee of $8.30. The total charge for the order is $179.05. So how many tickets were purchased? Well, remember that when you're reading this statement, when you get to that question of how many happened, that clues you into the variable you need to use, right? And so T is going to stand for the number of tickets purchased. Now, what other information do we know in this problem? We know that each ticket is $28. We know that the convenience fee is $2.75. And we know that the shipping fee is $8.30. And we know, the last piece, that the total amount is $179.05. So how do we build the equation that we need to write here? Well, we've got a total, right? So that means there are going to be multiple things added together, and all of those things are going to be added together equaling to $179.05. Now, what is going to happen on the left side of this equation? We got to deal with all the pieces, right? So I've got $28 for each ticket. And so when you see that terminology for each, you're going to be doing what operation? Times. And so I'm going to get 28 for each, what? Ticket. There's my tickets, right? It's my variable, 28t. Now, let's read the next piece. We've got this convenience fee, right? And it says the convenience fee is $2.75. But does it say the convenience fee is charged to each ticket? No. It's just a convenience fee for the order. And so I'm going to add $2.75. And finally, there's a shipping fee of $8.30. And again, is this a shipping fee for each ticket? No. It's a shipping fee for the entire order. So I'm going to add the $8.30. And so this is our equation. 28t plus $2.75 plus the $8.30 is equal to the $179.05. So now we need to solve this for t. And so we've got a couple different ways we could do this. We could talk about the like terms that are here and add these together first. So 28t plus, this is going to give us 1105 is equal to the 179.05. Now I can work to get things away from the variable t here. And so I'm going to subtract this 1105. And so when we do that, this will cancel. And I've got my 28t is equal to $168. And so then finally we're going to divide by both sides by 28. And so t is equal to 6 when we do 168 divided by 28. And so we could check this answer, we could plug this back in and do the 28 times the 6 plus the 2.75 plus the 830. Is that equal to the 179.05? And so we've got the 168 plus 275 plus 830. Again, is that equal to the 179.05? And then finally, adding all these together, we see 179.05 is equal to 179.05, which means it checks out, which means we do have the correct solution here. But remember, word problems require what? Word answers. I can hear you through the screen at me. Word problems require what? Word answers. You got it. So, what does this t equals 6 means? Come back to up here. T means what? The number of tickets purchased. So, how many tickets were purchased on the order? 6 tickets were purchased. Make sure that on these word problems, you relate it back to the situation, relate it back to what that number means. That's it for this video. Again, I could show you more problems, but it's all going to be the same process. It's going to be reading through that problem, understanding what information comes out to be able to write the equation, and then solving the equation is the same steps. And so at this point, it's on you to be able to practice this and understand what information comes out of each of these problems. So that's it for today. I hope y'all have a good one, and I'll catch y'all next time.